So we're just getting the noon stream show on the road here. I need 60 seconds to get Twitch running on my phone so I can monitor chat. And Twitch is doing a weird thing where it's okay there. Now we have the live stream going. So today's agenda, a couple weeks ago, kind of had this realization that some prominent lakes were missing from North America in Open Historical Map. These are lakes whose absence was inexcusable. And as I started poking around with a stick to see what was up, I found out that there was a mixture of issues. Sometimes lakes were simply missing, and sometimes lakes had been imported, but for reasons the imports were broken, and they weren't even broken consistently. So for example, zoom out here a little bit. Down here, bottom, slightly left of center, is the Great Sacandaga Lake or Sacandaga Reservoir, artificial lake that started filling when the dam was completed in 1930. Pretty big. I went to look at it and found that there was lakeshore, waterway, riverbank, bunch of ways tagged waterway, riverbank, no complete relation. There was a gap in the set of ways, so there was no rational way that anybody could possibly actually render it. So I ended up basically filling in the missing piece using aerial imagery and creating the relation and modernizing the tagging from riverbank to the natural water. But the other thing, the even bigger omissions I saw were that Lake Huron and Lake Superior were not rendering at all. I've done a lot of work on Lake Huron and have more to do. In the next stream I do an Open Historical Map, we'll look at the workflow for bringing islands back from the dead. What happened with Lake Huron and Lake Superior, there were actually relations there. Tagging was funky because apparently back in the Mapnik days, 10 plus years ago, they had to use natural coastline tagging because of the size of the Great Lakes, and the relations, the ways were not in order. And since we changed renderers 2 years ago, the current renderer, the vector renderer, wasn't handling those. I don't know if OpenStreetMap Carto would handle those. It has never had to because Open Historical Map has never used Carto. But people who are experienced with this tell me that Carto is a pain. Excuse me, not that Carto is a pain, but the Great Lakes are a pain. And after my experience, I believe them. So here's OpenStreetMap. Lake George is right here. Switch to Open Historical Map at the exact same zoom and longitude, latitude. Lake George is missing. Flip over here, and this is the south bay of, well, that's the south bay. This is the south end of Lake Champlain. We see that's here in Open Historical Map. The only reason that's here is because 2 weeks ago or a week ago or whatever, I imported it. So we need to somehow get Lake George into Open Historical Map, and I decided to make that today's subject. Where do we get Lake George from? Well, in theory, we could just take it out of OpenStreetMap. In practice, it is highly likely that various mappers have edited the boundaries of Lake George. A lot of active mapping in the area. So permissions become a problem because of the ODBL for OpenStreetMap. There's an alternative method that's not really any more difficult. It's a little different. It's to go to the USGS website and download National Hydrological Database shapefile for the area and pick out the Lake George polygon. And that's the way we're going to do it, because that stuff is public domain because it's a U.S. government product and we don't need to get permission from anybody. So, switching to a tab here, apps.nationalmap.org downloader. And I'll stick a link out there somewhere. May not be that easy, but we'll see how that goes. USGS downloads are a little bit wacky. They actually have 3 download sites. There's one called TopoView, which is good for fetching historical topo maps. There's one called Earth Explorer, which is good for fetching old aerial imagery, public domain aerial imagery. And then there's this one, the National Map Downloader. I have more experience with TopoView and Earth Explorer. I see that there is a way to download historical topographic maps here, and I don't know if that's duplicative of TopoView or not. It's a little frustrating to me that it's spread across 3 sites, because the basic UI sequence is sort of similar for all of them. You zoom in on a spot where you want to download and then, download. But they have different UIs because they were done as different projects. And so it's just, this is a small rant on my part. This could be unified and this could be easier for all of us, and it's not. And that's aggravating. I also see that there's an opportunity for imagery. It looks like one particular set of imagery, the NAIP, so that's probably not the historical imagery that I'm used to from Earth Explorer. I'll have to research that. That might be a topic for another stream, is the differences between the sites. But we're interested in hydrography, so we're interested in NHD, which is right here under this category. So I'm going to check off NHD. And I want to select National Hydrography Database. I just want the classical NHD shapefiles. We don't really need high resolution. The NHD is already excessive resolution. From our point of view. Okay, I want the shapefile. So here I have a choice. File GDB could be useful if we were looping through QGIS. I haven't used this guy a lot, so that's one of the challenges. Is this interface is not quite second nature to me yet. So this is a help file that doesn't do that much for us right now. So we've zoomed in. Click on search. Okay, there we go, search products. Okay, so, and again, this is just basically first one here is a shapefile of the HU8 subbasin, so click on footprint. Okay, so HU8 is not going to get us what we want. This is getting us even less. This gets us most of it, but let's see if we can do better. Okay, this one gets us all of it. In fact, this is the one that I used previously because it also gets all of Lake Champlain. And as it happens, I've already downloaded this. So yeah, I can get a download link for the zip file, but I don't need to download it because I've already got it. So we're going to skip that step. We don't need to do it because I've opened it up. So now we're going to go take a quick look. It's under Projects NHD here on my MacBook. So I downloaded it and unpacked the shapefile. The shapefile's right there. I unzipped it. You know, that's like all it is a zip file, nothing really radical here. And then you have the subsidiary shapefiles underneath, and you have a variety of them which contain different kinds of things. And what we're going to want is the one labeled NHD waterbody. And I don't do anything right here except observe that that's where the file we want is. There are other things that might show up in NHD area depending on, you know, what it is you're trying to do, because sometimes NHD area is going to give you something like the banks of a wide river that you would like to bring in. I used that at one end of the Great Sacandaga Reservoir. But really that's just about, you know, where the data is. So I've already started up JOSM here because that is my preferred editor. I claim total ignorance of ID. I might like ID if I ever spent the time learning to use it, but my comfort zone is JOSM, so that's where we are. So I'm downloading from Open Historical Map area straddling Lake George. I just want to mention this to it for any observers, is that it's showing us Open Street Map here, and you might say, well, it should be Open Historic Map. We're running JOSM on OHM. But I find this really useful because I get oriented using OpenStreetMap when I go off to edit Open Historical Map. So we are looking here, and indeed we don't really see anything of Lake George. I'm looking at this, and I'm seeing riverbank tagging. I saw some weird riverbank tagging with layer 1, and I don't really have the slightest idea what that's about. Any place you see waterway riverbank tagging, you should probably be thinking about modernization to use natural water. Big effort to do that over an OpenStreetMap. Right now, I think that Open Historic Map needs to follow along, but you know, there's not really a timeline for that, so we're pretty okay with that. So we've got Shroon River, which is a center line. Nobody's mapped the banks. Not really a blistering need to do that. So let's go to Open Recent. And I have most recently actually downloaded that water body, so I'll just use Open Recent and fetch it again. And the shapefile is kind of big. 4,630 features. But there is value in opening the shapefile in the stream, so I did not pre-open it, or rather I pre-opened it in JOSM earlier just to verify the sequence and then closed it because I wasn't in the stream yet, knowing I can always do it over. And I'm going to move this out of the way, and now I see that the error message follows it. Now this message is one that you will get, and I want to talk my way through it because it's actually significant. And you need to understand what it's telling you, because it's telling you do not upload such data to OSM And we're going to be ignoring that message, but we have a good reason to. You should not ignore it unless you know the reason why you're ignoring it. Well, the first thing is it's do not upload to OSM, and we're uploading to OHM, but that's a casual, pedantic, stupid discussion. And we should not tolerate it. JOSM was unable to find a strict mathematical transformation between GCS North America in 1983 and WGS 84. Well, basically, it doesn't recognize the transform from the data set that the shapefile's in. It happens to be in NAD 83, which is a standard North American set, but a text string is not matching. And that's likely a finicky detail that you could correct with a pull request for JOSM, but I haven't gone to the trouble. And the reason is that NAD 1983 and WGS 84, WGS 84 is a standard worldwide coordinate system that OSM uses along with almost everybody else now. The difference between these two transforms is so tiny that it's not worth worrying about for a case like this. So we're going to use the lenient method, which is warning us that it's non-precise and may produce 1 kilometer location errors, knowing that because it's NAD 83 and WGS 84 that that's not actually going to happen. So we click continue and let it run. The actual errors are going to be on the order of 1 to 2 meters, which for this application is not a big deal. I mean, mapping by hand from aerial imagery, we would probably achieve that at best. But additionally, we're going to run a simplify, and the simplify is going to eliminate a certain amount of the precision that flows from the import. So there's not really a need to get paranoid about the transform error given what we're about to do. So pardon me while I fuss with this mouse sharing program. This mouse sharing program is really annoying, and I'm going to switch to one that I think is better at some point here, but in the meantime I'm just complaining, so don't mind me. So let's change what we're looking at temporarily to data layer 1. And this is where we were looking at Lake George. So we're doing this just so that we can then loop back over here. And we see that it's a multi-polygon with 62 members. So it's this one. The multi-polygon with 82 members is almost certainly Lake Champlain, and it's South Bay. So we want the 62 member one. And so that's our current selection. So this is a really easy step. We're going to edit, merge selection. And that's going to pick this entire selection and give us the option to merge it into data layer 1, which is where we just downloaded OSM, and drop it. Now, isn't that easy? Now we switch back over here, and we have this multi-polygon, and let's double click on this sucker, launch the editor. We see that it's already got all the inner and outer ways the way we want them. I am temporarily going to retain the NHD tags. I'm going to put NHD colon in front of them so they're not in the general namespace, but in a namespace for NHD tags. there's an argument that is made that we should get rid of these if they're not useful, but I don't know what they all are, and I don't know who might have a use for these. And because we're not importing a huge number of these things, it's not really a lot of tags taking up space. And it's a multi-polygon. That's an OSM tag. And we need to give it the name. So now what do we got to do? This thing's got a lot of nodes in it. Look, we got 1,628 nodes in these outer ways. We need to simplify. Shift Y is simplify. Or is it? There we go. Simplify away. So we can cut the number of nodes in half with the simplify. Well worth it. So this outer node now contains a lot fewer nodes. So now we go Shift Y on this guy. It's selected. And it turns out it takes a minute for that pop-up to come up, which I did not know before. Let's try that again. Okay, simplifying away. It's not a blisteringly fast process, but it is certainly getting rid of nodes, which is what we need right now. I can hear the fan on my MacBook running along, trying to keep the overheated processor going. Now this is, of course, a modern shoreline for Lake George. We'll go take a look at the north end of the lake when we are done with this. And the other thing we're going to do, just as a sanity check, I have a measure of confidence. Okay, I'm not sure why that simplification hasn't finished yet. I'm wondering if it actually... Yeah, I'm not quite sure what's going on there. Oh, okay, there the outer thing did finish, so now we seem to be running another one. But in any case, coming back to my discussion, we'll look at aerial imagery just to verify that our shoreline isn't too wacky, but it should be good. I'm fairly happy with the way Lake Champlain went, although I should have run a simplify before I uploaded it, and I may at some point do a simplifier on the boundaries of Lake Champlain just to reduce the number of nodes, because the high numbers of nodes slow down the processing in the API, uploads and so forth all seem to go slower. you almost get the impression that these simplifies are running in the background. I don't know if that's really true, but the UI is certainly not disabled. And it is a multi-threaded CPU, so maybe this is all happening. Yeah, you see we've got mostly reduced outer ways at this point. This is kind of new territory for me too, because I haven't had to do the complexity reduction on something like this before. Well, I should have done it on Lake Champlain a week ago and I didn't, so now we're on the learning curve. So click simplify. Then I've got the one outer down there that doesn't look simplified. And that's that piece down there at the bottom, which I didn't realize was a separate piece and skipped over. So start simplify on that and see how long that takes. Okay. Got one left. That was one we did early, and I guess it didn't really ever complete, so let's try simplify on it again. But that should be all of the outer nodes. And then we'll do a scan over the inners. And there's one inner here with a bunch of nodes, so we'll go ahead and run simplify on that. Gives me a history thing, but I cannot actually get history because it's a fresh upload, which I sort of expected. So I'm not sure these last two simplify doesn't seem to be running. Now looking, I don't see simplify in tools. Well, not everything is bound to a tool anyway. I was thinking maybe it wasn't refreshing properly, but I close it and reopen it, and I still don't have simplification. There. There we go, that one simplified. You know what? I've simplified the outers, which are the big problem. So let's just go inspect the imagery. The outers are where all the nodes were. The inners can keep all their excessive nodes. Now we got Maxar imagery up. And we can do a quick look and we can see that in fact it's pretty good. You want to come look at the north end though. The north end, Lake George, connects to the Lachute River. And actually what we're looking at here on this really slow download, this is why I should have simplified Lake Champlain, because we're catching a piece of Lake Champlain here. And without simplification, so the Lachute River here connects Lake George to Lake Champlain. That was something I didn't do that I need to. Let's go get that quick while I remember. Lake George. The other thing we got to do, natural water. Okay, now let's go zoom in on the connection of Lachute River to Lake George. Lake George basically drains here. We don't have a polygon for Lachute River, but we can at least connect it to the Lake George outline. That's kind of not completely necessary, but worthwhile. But basically, Lachute River, it's not a navigable river. It's got a significant chunk of falls because it's dropping a couple hundred feet from Lake George to Lake Champlain. But I wanted to make sure that this was kind of in the right place. There's probably an interesting research project on historical shorelines of Lake George because there are some small hydro dams at the north end where it empties. But as a practical matter, what we have accomplished here is we verified that this simplified shoreline is pretty good. We've got it tagged correctly. And so it is in fact time to declare victory. Click the upload button. And Lakeshore for Lake George in NHD dataset with the lakeshore verified against Maxar imagery. So it's big enough, nearly 9,000 objects, that it's going to take 9 change sets. So we're just going to go click on upload and let it run, because it's going to take a little while. Still a lot faster than the upload Lake Champlain took. And there will be a little bit of a delay for it to show up rendering in Open Historical Map, because there's a process behind the scenes. So yeah, we can't get instant gratification, and that's actually just fine. And I'm going to declare victory for today's stream when the upload completes. And then the next time we come back, we're going to be looking at the workflow that I have crafted for fixing up islands as members of the Lake Huron multi-polygon, because there's a boatload of islands in Lake Huron, and it's if you do it at onesies, it's going to take years and cost millions of lives. I did a little bit of that, and I ain't doing no more because I've got something that works better. So that's 5 out of 9 change sets. Yeah, that was a thing I did not understand. I screwed up some early Lake Champlain change sets. I didn't realize they were in multiple change sets, and so I was trying to revert them so I could do them over again correctly, and it's like, these nodes don't go away, why not? It's like, well, yeah, you kept reverting one change set over and over again, and they were in a different one, so yeah, you know, doctor, it hurts when I do this. Well, don't do that. Yeah, the historical importance of Lake George, you know, throughout the French and Indian Wars and into the American Revolution, there was just a lot of conflict, movement, and control changing hands in this area. It's a complicated story, and who knows, perhaps when mapping is further along, I will tell that story in a live stream. I've led physical tours of the area from Crown Point on Lake Champlain south to the Saratoga battlefield, talking about 1775 through 1777. And I see Texan Space Agency has popped in, and he's just noticed it's not Swift, but this is an OHM mapping day, and you know that perfectly well. And I am almost done with this stream today, but good to see you. This will, of course, be on Twitch for about 30 days, and then this is one that I'm going to upload to YouTube, because I think that showing the workflow to download an NHD file to work with in JOSM is worth documenting. Yeah, it's a good stream today. It covered something that I don't think has been covered before, and I'm glad to get it out there. But now nature calls, so I'm going to have to cut this short. And talk to you, message to you on Discord. Yeah, you know, there's an OSM World Discord. There's OSM on Slack. There are lots of places for people to talk about this stuff. So until next time.